Good evening, friends. Welcome to Eason Academy. We are into controller programming as a part of embedded system programming, and we are at session 4. And in the previous session, we discussed about the LCD controller. And this session, we are going to discuss about timer controller. That's one of the very the most important controller you should learn is a timer. Your whole system. For example, if you take an operating system, that itself is nowadays working on timer tick. Timer plays a very vital role in embedded system. Embedded system means electronics. Okay, electronics means real time. So real time means it's all based on time. So you need to be very clear about timer controllers. That's most important. But there's a big problem that you have to understand. When you study in the college, your syllabus, you have something called 8085 and 8253 timers. Am I right? Those timers came in the 1980s, 79s, 80s. And that's why IBM also used in their first PCs that timer, 8253. That's all in 70s, between 70s and 90s that controllers came, 8253 and all. If you could able to understand those controllers, that is 8255, 8253, and 8257, 8237, they're all very simple, easy to understand. But now the trick here is these people making a chip nowadays for the industry application, not for teaching, not for a student to learn. Please understand, don't get confused. That this is a very important. Nobody make a chips for student to understand. And this is a very important. All the chips are made for industrial applications. Trying to make a product. They want the industry to buy the chip. Then they'll make money. They are running business. They are not running charity. So people do not make any chip for the industry, for the college. So all the chips will be only complex because they have all the options available inside the controller. You have to select a very simple one right initially and start doing that. That is basically how do you configure the board? That's a trick. That's called very important. The mode in which you are configuring it. So let us understand what is a timer. The very simple timer is simple. I have a controller. And I, as a CPU, write a value to the controller. Let us say 1000. Then I give a clock from outside. The clock is a width. Let us assume the clock is a 1 megahertz. That means the duration is 1 microsecond. It's a 1 microsecond duration. So if the clock duration is 1 microsecond, I've written the value 1000. Now I set one more bit called start. When I say start, this game will start decrementing the 1000 into 1000, 99, 999, 998. Like that, it will start decrementing based on the clock. Whenever the clock comes, every rising edge, this will be decremented to 999, 998, like that. Understand? This will be decremented. The moment this value becomes 0, okay, the timer will stop. The timer will stop, and set a bit here called done, done bit, let us name done bit, or over, name anything or completed, whatever it is. So I have so many registers. One register is called start. This is called status. This is called control. In control, you are making to start. In status, you are trying to read it. And you have one more register to have a count. What you have to do as a CPU, you have to go on, this bit is, let us say, normally 0. When the count becomes 0, he will set it to 1. So as a CPU, go and read the loop in the loop, the while loop. While 1, if star in equal to 0x1, then break. Till that become 1, you will be in the loop. But once again, if you are loop, you are wasting the time. Then people thought how to avoid this time. Now, the trick here is you write a program. They say this register is 30, 31, 30, say 80, 81, 82, assuming. I say star out, char star out. Out is equal to char star out. Out is equal to 0x30. Star out is equal to, sorry, I don't want this. I want this 81, 31. I'll say is equal to 1000. Now 1000 is written here. Then I say out is equal to 0x32. Star out is equal to 0x01. That means start. Now you start decrementing. Now I say while 1, you'll check for this guy, 80. That's where you write a program. Now the problem is this. We are wasting the time. When that guy is doing that, see, for example, when you give a job to the driver to drive a car to somewhere, to airport. If you keep on asking him, the airport has come or not, then you're wasting the time. Then why you have a driver? You can drive the car. Why do you waste the time? Now what you do, you give a command to driver. You give a command to driver, then you start doing your work, working on laptop. Now, once the airport is reached, the driver will tell you that, sir, the airport has come. Am I right? That's the way things are working. What you do, you work on a laptop. When the driver said the airport has come, you will close the laptop and then you will start getting into the airport. After you get into the plane, you will open the laptop, you will continue from where you left. This is called, that's why it is called, you are doing some work. During the work, he is giving a signal. It's called interrupt. This is called interrupt. Like that, there is a signal available from the timer to the CPU called interrupt. The moment the count becomes 0, when you begin a start, when the moment count becomes 0, he will set this bit 1, status bit. Also, he will give the interrupt. When he gives the interrupt, what the CPU will do? This is what the thing you have to understand. Very important. Let's say you have a function called add. The main. you call the add function. That time the add will be called. So your software is calling a function. Your software is calling a function. Now let us assume that I have a thing called change LED. It's the change LED, a function. Now I say that star out is equal to star out XR with 0x01. What I mean now? Do you understand this? What I'm doing now? Star out is equal to star out 0x01. Since this is XR, let us assume initially it is 0. LED is off. The bit 0. I do only bit 01. Now I read it back. Now it is 0000. LED is off. I make it to XR 01. So 000. If you make a XR, I will get 000 and 0001 means 1. So now this become 1. Now LED become on. Now once again, now the value is 1. So if we read it becomes 1. Star out. I XR with 0000 1 means 0 now. Now the LED become off. So if you write a program now, I'll just give you the program now. We will write a small program itself, then you will understand. Let us write a small program, then you will understand. Then only we should write a programs to understand things. Otherwise, we don't understand. Let's see. Time is 20. Let's see. Now how fast we are writing this program. It is very important for us. Okay. Now let us make this one guy. Let's make a small, because I want to connect here. So let me rotate it. See, I've just rotated it. It has come here. Now 0. Let me connect to the 01 LED. LED. So then I add a resistor. Connected to ground. Any ground is here? Yeah, ground is here. Oh, I did not rotate. Sorry. I thought I rotated here. Where is the rotate gone? Sorry, friends. Yeah, now it's done. That time it's not rotated. I didn't know why. Now I connect them. Same thing. I take the ground. Connected. Now, if I connect on port 0, I can do that. See here. I write. We make it on. Okay, I say. I think it should work. Am I right? So, any mistake? Well, address is mentioned as pointer. Tell me which line is, which line of the code? Please let me know. Which line of the code is a fault?
Sir, when we are mentioning char star dirf direction f, so below that we are writing star without star we are writing dirf equals to address.
Yeah, that both the thing I combined on one line. Both I combined on one line. This is what the meaning of that. I combined both. Normally we write this way. Normally we write this way. Am I right? Normally we write the code this way. Normally we write like this. Am I right? We write
Yes.
here DIRF is equal to 0x30. Out f is equal to 0x31. Am I right?
Yes.
But you can instead of doing like this, you can do that. That is what I have done. This is what pointer initialization. 30. You're supposed to write like this. They're only industry like this. Okay. Now let us write the program. Let me run the program. See, LED is blinking. Very simple. Now I make a function here. I make a function here. Change void, change LED. I write the whole thing here. Sorry, I put here while here. Change Understand? Now I'm calling only the change LED as a function. Now I put the long I here, but out. I change the out here. So you understand now, I made a separate function now. And I'm calling the function here. It's not working. What is a mistake? Oh, sorry. See that? It is. Every time when I call the function, it's changing. If you increase the delay, it will do that. It will do slowly. This all we know that. This is what we know. Am I right? But what we are now discussing is this change LED function. If I don't call this, let us say, if I don't call the change LED, you're gone. This LED will not be blinking. Is it possible to make the change LEDs to blink? That is what our trick now. But that means that you will not call the function in the software. You will not call the function, but that function will be executed by the system. Now I'll show you that. I'll show you the code now. Then we will discuss that. Before we get into the thing, first I'll show you that a small demo of the code. Once we see a demo, then you will be able to understand what is a code. The same way, there's no difference here. What we did, the same thing, I've done it here. I have a same thing here. You see that same LED, but instead of change LED, I call that function as a ISR. I'll tell you why it is. Why it is. Now I do same thing. You see here, port F data, I'm changing it to 01. Am I right? The same code, what I've written here, the same code I've written here. No change. But let us execute now. Let me execute now. But understand here, this is a function name is called ISR. I don't call the function anywhere here. Here in my for loop, I'm doing serial println that is going to print only on the screen. That the J is going to be from 0 to it's 0, then incrementing. I'm going to print only J. But and the time is here. Let us assume that I make it as a less time. 50,000. Understand? Now the J is going to print on the screen, but I'm not calling the function. See, this is what my code. See the code now. If you see the code, I do volatile I, fine. Okay, forget about this. These two we'll discuss later. I say serial begin. Then I'm in a while loop. I'm not getting out of the loop. The while loop, I have a small delay. I do a small print, which I'm doing that. So this is a job. Now I don't do this. I don't do this init timer. Now I run the code. Let us see what is happening. See, 0, 1, 2. It is printing, am I right? You see that. Let me make this as a let us make this as a big one, full screen. Now I run the code. See here, you get here 0, 1, 2, 3 like that on the screen. but nothing is happening. This is what my code. But if you see my same thing, if I just remove the init timer, but init timer is nothing. Init timer is it just only it does some more small work. There's no loop or anything here. But still, if I see here, if I run it, now you see here, I run the code now. Now you see what is happening. See, the 0, 1, 2 is printing and the LED is also blinking now. Now, who is calling the ISR function? That's a big trick. First time, a function is called by the hardware, not by the software. Okay, let's go to the board. Let's go to the board. I'll explain to you that how the screen is, how the hardware is calling a function. So what happened? I have a main function. I do a while loop. While 1. That I give a small delay for I is equal to 0, I less than 50,000, I plus plus. I say println serial. Okay, now this J plus plus. I print J. And the J is printing. So this is a while loop, while 1. It never comes out of the loop. But I have a function called change LED. Who is calling the function? That's a trick. Now, the function is called by a signal into the microprocessor. This signal is called interrupt. When the interrupt comes, then the microprocessor will stop this. It will go here and execute this. It will come back to this. This function is called ISR. And the microprocessor have so many interrupts like this. And this is, we are using timer. So what they have done it is, in the software, they say that ISR, you call the name of the interrupt. Name of interrupt. How do you know the name of the interrupt? That is here. You go to the data sheet of the chip. You go to the data sheet of the chip. Then where is interrupts? Here interrupts. See, if you see here, see they're given a source. See here they're given a source. You can see page number 101. Reset. Interrupt. This is called external interrupt. Then timer. You see the timer when there's a compare interrupt. Compare match A. I will discuss about that now. What is a compare? Then compare B. If you see our code, okay, we have explained here. Timer 1, compare A. Okay, vector means address. Forget about vector. The word vector is representing, you can call it as a timer 1, compare A, address. That's called vector. Here we call vector. So timer 1, compare A. So if you go to the data sheet, you will see that timer 1, compare A. Who gives you this? Then you go to the timer. The timer, you go to the block diagram. See here, timer 1, compare A. Interrupt requests. There are two interrupt requests are given, B and A. And the N represent various timers. If you see here, if you see this data sheet here, sorry, the interrupts. See here, I have timer 2, timer 1, and timer 0. See that? Timer 0, compare B. Timer 0, that means that I have so many timers. As we always explain to you that the chip can have n number of, you see the block diagram. See the block diagram of chip. See here, this guy has how many timers? See it? Timer 0, timer 1, timer 2. He has so many timers. Timer 4, timer 5 is also there. See? So many timers are there. Timer 0, timer 1, timer 2, timer 3, timer 4, timer 5. It has 6 timers are there inside the chip. Now that timer value, we are setting at this. Now, what is happening inside the chip? This is what the block diagram of the chip. There's a timer. Now we are using timer 1 because the 16-bit, the timer 0 is 8-bit. That's why I use timer 1. I can give more time. Now, in the timer 1, if you go here, that is what I told you. If you see the block diagram, you will get confused. But I'll try to explain to you that without confusing. Without confusing, I'll try to explain to you that. Now, this guy is getting a clock, the logic. And there is a count register. Understand? There is a. Do you see this? Or you have to make it big? See here. Now, this guy is having a register called. This is timer 0. Oh, this is 8-bit timer. Let's go to 16-bit timer. Okay. Let's do 8-bit itself. That is easy to understand. Then we can go. See here. If we click, this guy is going. Now, there is a thing called timer count. That's why you are putting the value. Then there is a OCR. That's the compare register. Now, this guy is comparing. If this register are equal, this guy is incrementing. See that? The control is incrementing the thing count. So whenever the count comes, this guy will increment. That is. Don't try to understand the full block diagram. It will take very tough. If you give a clock from outside, the prescaler will divide the clock and give it here. Okay. This is called prescaler. Now, so this is what prescaler. Divide the clock. Now, I have a timer. The count will be incrementing. The moment that is become equal to the OCR, then that output will be, interrupt will be given. Or you can make it as a waveform on the, this guy has, see, if you have a time, please read this full timer. This is a very interesting topic. This topic is very interesting. And as I mentioned to you that you need to understand about timers, IO ports, interrupt. It's all common for everyone. Now, if you see here the timers, let us go to the timer 1 or timer 1. Now you see here, they have a registers. If you see the registers, N number. Let me give you the register page, then you will understand. They have that mode of operation. See here, as I mentioned to you that, you see that this is what mostly you get confused. This guy has how many modes? Your normal mode, timer mode. Okay. Second one, PWM, pulse width the modulation. Yeah, pulse width modulation 9-bit. pulse width modulation 10 bit. Clear the counter. That means that when you become reached, then clear the count to 0 once again. Automatically count from 0 once again. So you do not have to do anything. Then fast PWM. PWM phase and frequency correction. Phase correction. See that how many modes. So if you start trying to understand all the modes, you are confused. Now we are going to work on this clear timer on compare match. So if you make this bit as a 1, okay, CTC mode, that you can see here. Only this bit is 1. The CTC mode, this bit is 1. All the other bits are zeros. That's what they've explained. So if you slowly try to understand all the modes, then be very nice. You'll be able to do all the motor control. Everything is based on that PWM. And I can also help you out. It's a very, otherwise I'll make a small video and share it. I have to have a lot of videos are pending that we try to make from tomorrow, one videos. So these don't worry about these modes. We are worrying about only clear. Now, what is a compare match? See here, compare match unit, what it does. So when there is a two values of compare. Here, sorry. See, they've written here, the compare match output value. Say compare unit. Let us say compare unit first. See here, they compare the registers. When the comparator becomes successful, they give you the interrupt. Or they generate a waveform. That depends on your setting. If you set, I want a waveform, then you will get a waveform. Otherwise, you'll get the interrupt. These are all the programming concept. Now, in the interrupt register also, after I set the interrupt here, then I go to the interrupt register. There, I can set here. In the interrupt, I have registers. Then I can set the register here. Which I want the interrupt to come or not, enable, disable interrupt. All those things are there in that. See this mask. See that interrupt mask register. You can mask the register or you can unmask the register. Here, see here. See? This is called mask. If you put 0, then that interrupt is disabled. This is all external interrupt, and there are some internal interrupts also. See here, these are all the control registers. So this we'll try to see some time later about interrupt. So I'll try to show you the. I've just given you that. If you would like to understand this thing, try to understand the interrupt. These are all. If I explain any number of time you don't understand, you try to read it, and if you have a doubt, ask me. So how many pages? It's all very simple only. Yeah, there are here. That is what here. This is what I say global interrupt enable disable. See here, interrupt vector change enable. I'll show you one more here. That's register summary. There. Here is all the interrupts things. All the things are available here. And here you see that there is an interrupt called timer mask. You are masking the timer, and you are all the interrupt sources are available here. You can enable or disable any interrupt as you wish. And we are going to do the OCR A. Am I right? What is that? Mask 1, that is 6F. Timer mask 1. So we are going to enable this. So understand this is 6F. We need a timer mask 1. And we are going to enable the OCR and enable the interrupt. This is what we're going to do. Let me go back to the code now. Then you will understand the code. The code here. See here in the code. Now we have only one function called here is init timer. What the init timer does, there are 3 registers: timer control register, timer 1 A, B, and then mask, and the OCR value and the count value. Count value I make it 0 initially. That means that it starts from 0. Now I'll take the board also. Along with the board, I'll explain to you what are these things. Along with the board, I'll explain to you that then you will understand that. So see that. Now I'll write it here. Now I make it here TC CR1A. What is that? That is timer control register. I'm making it 0. That means that I'm not going to use any control. And timer control register 1B. I've written here 0 initially. Then count. All, if you see that, the trick here is I have 1A, 1B. That means that 1 is the timer. I told you that we have 6 timers. This is one of the timers. And 0 to 5. And the A says that I have A and 2 sections are there. We are only comparing that. For example, when you do PWM, you change one width more, one width less. This you use A, this you use B. For that only they have 2 counters inside one timer counter. And I'm using only counter 1 and make it 0. Now see here, I'm initializing the value as 60,000. That means that the count is 0. When the 0 reaches 60,000 and there's a 16-bit, I cannot more than that. Then you see here, I have a timer B is mode. I give 1C, 0C. You try to understand. I've written here, I'm making 256 free scalar and CTC mode. Now you should be able to understand that. When you want the code, I'll share this and you can understand. Then the mask 02. That means that I enable only that interrupt. Timer compare interrupt, which I showed you the data sheet. The data sheet I showed you that bit here. Your address is 6F. Then I said that enable 1A, not 1B, or enable out. I do that. I do only the compare output compare register. I do that. So that is what this code. Now when I do that, when I remove the bit, when I start the code, see here the 6F. I have all the addresses. You go and read all the addresses. What are these things? Take this program as a reference. Now I have told the compiler, you put the ISR in the timer compare. This is what one vector, one address. I have multiple address for multiple interrupt sources, which I've shown you that multiple interrupt sources. When I execute this program, what is happening? That is the trick. When I execute the program, the LED is blinking. How come? This is coming by the hardware. Please understand, this function is called by hardware. This has to be understood. The ISR function is not called by anybody. You don't call anywhere, but you declared only the function, which is called by hardware. If you change the vector, then that vector will be called. I mean, I have so many vectors, which I shown you that in the data sheet. The data sheet, I shown that I have so many vectors on so many interrupts. You think that's a very small chip, Arduino, but you see that guy is having so much of programmer thing, all the interrupts, external interrupts, timers, so UART, SPI, analog comparator, ADC, complete, so many things. So understand that. This is next, when we have a time, that is next week. First session, I'll talk about the interrupt, how the interrupt is working and all, because you need to understand the interrupt controller thoroughly. That is the most important part in our system. First one is timer, LCD timer. But a timer I've explained very, very simple. I've explained it 10%. If you have to understand the full timer, then you need to do more. You have to read them all. If you change the, you can write a program for various timers and try to find out that you can able to do the, see, basically you should find out whether the chip listen to you or not. But instead of doing like this, you can call a function in Arduino and that does not work. You don't understand these things, how the timer is initialized and how it is working and everything. So if anytime you want the code, and let me know, I'll be able to study the code. So now I'll give you a top level concept there before we get in. Now, you see here, we have a count register that is counted by somebody has given a logic. This guy takes a clock. That clock can be divided by any number, because if you change the width, you'll be change the count. Then I have an output compare register. Both are getting compared. Right now in our code, we fix this to 60,000. When the clock comes, this guy reaches 60,000. This guy will give you the interrupt. Also, when this goes here, this guy will give a clear signal. This becomes 0. Once it becomes 60,000, then it start counting once again from 0 to 60,000. That is the mode we have selected called CTC mode. Clear on count. That is what CTC. Clear timer count. That's it, CTC. But you have so many modes are there. So this is what goes to the interrupt. We have written an interrupt function for this. That ISR function, OCR A, ISR function will be called the moment interrupt comes. And it will call only once. Every time interrupt comes, this will be called once. But internally, what we are doing is we are changing the LED. If it is on, we make it off. If it is off, we make it on. So this is called interrupt service routine. About interrupt, we will have another session. It's an interrupt and DMA. Those are to be understood by you as a part of the system. This I have explained a very, very simple timer operation. But nowadays they make simple. If you take 8051, if you take 8051, the timer is very simple. The timer is very simple, not much. But if you use this ADMACA chip 2560, that has too many options. And like this, they have 6 timers. You can use it for control so many motors with outside. You see, that we will discuss on the when it comes to motor control, we will discuss about that. Okay. So if you have any doubt, you can ask me. And if anybody wanted, I'll start this timer code, which I've shown you today. Yeah. Now everything works without AVR library. I don't use any AVR library. See here. You see this, I'm not using any AVR library. Now the whole thing works without AVR library. Please understand. That is the trick of our mechanism. Our methodology never use AVR library at all. That's the beauty. See, this is also one thing. Oh, fine. Now I know that you are small doubt. I'll show you one thing here. What is the value of this timer thing counter? Timer 1, compare A is 22. Am I right? Okay. Now let us see here. Since here, I say here, instead of this, I call here.
The screen is not shared.
Oh, okay, I'll do that. I'll share the screen, sorry. Is it visible now?
Yes, sir. Now it's visible.
Yeah. Now I do one thing. I call here ISR 0x22. Instead of calling this timer 1 compare a vector, I'm calling just 22 because that is what the document here says. Let me stop it. The document says that is 22. Am I right? I've never tried. I'm trying just because of your asked. Let me. I don't know if it will work or not. If it does not work, I'll find out why. I'll let you know. Oh, this guy is having some expected, some different argument. Okay, something else. That's it. So that I have to find out what is the code. He expects something. So this I have to find out. I'll let you know that. This is something else. Maybe a constant or some. I have to see that what the ISR looks for here. So I have to now go to find out the function. Let you know by WhatsApp. I'll tell you that what is ISR looks for. But this is not the Arduino library. This is actually the compiler directive ISR. There's actually an interrupt. Okay, this function is called by you. So see, I cannot give you the full thing of this. I can give you the idea only. It's up to you to practice and come to the level. If you do not practice much, you don't understand these things. But this is all very important. Don't think that it's a very simple chip. Learn it. The same thing is going to work on your ARM board. Okay. I'll call you after class. Okay. So try out these things. I'll share the code and try out these things and see that how much you are going to the next level. This all, the more you practice, I can discuss more on these things. Okay.